Good afternoon, everyone, and thank you for joining us today. My name is Joey Minervini, and I am the Public Affairs Manager for the Americas here at the Global CCS Institute. Before we get into the content, I want to let everyone know that this webinar will be recorded and posted to our website, and we will also post the slides that we present today, so those will be available for download following the webinar. Next slide, please. I'd like to briefly introduce the Institute to anyone who may be joining us for the first time and unfamiliar with who we are. The Institute is an international, not-for-profit think tank focused on accelerating the deployment of CCS across the globe. We achieve that by through providing fact-based, influential advocacy, catalytic thought leadership, and authoritative knowledge sharing. We have offices in major cities across the world, including Washington, D.C., London, Brussels, Abu Dhabi, Melbourne, Tokyo, and Beijing. And we have a membership comprising more than 200 governments, global corporations, research institutions, technology companies, and non-governmental organizations, all of whom are committed to CCS as an integrated part of a net zero emissions future. Next slide, please. The reason we are here today is to share our newest thought leadership report, Building Our Way to Net Zero CO2 Pipelines in the United States. And this report is the result of a months-long effort from the Institute and some outstanding partners who I'd like to quickly acknowledge and thank now. First, I'd like to thank our collaborators, Ryan Kammer and Emma Tomley of the Great Plains Institute, Josie Long of Process Performance Improvement Consultants, and Ramon Hill-Eggy of the University of Texas Bureau of Economic Geology. Your many hours of time and contributions to this report were critical to its success, so thank you all very much. I'd also like to thank our primary authors, Jamie Burrows, head of CCUS Venture at DNV, and my colleagues at the Institute, Hugh Barlow, Carbon Capture Technologies Lead, and Errol Pinto, Senior Policy and Commercial Lead. Both will be joining us today and presenting today. I'd also like to thank the individuals at the U.S. Department of Energy and the Pipeline and Hazardous Materials Safety Administration, or PHMSA, who provided thoughtful review and comments on the report. During today's webinar, the primary authors will speak to the sections they wrote, with the exception of Jamie Burrows, who was unable to attend. And in Jamie's place, we will have John Godfrey, Senior Principal Consultant, Integrity Solutions and Compliance, Energy Systems at DNV. He'll be presenting Jamie's section. John will also be a panelist during our panel discussion, and we're fortunate to have Max Kiba, Director, Program Development Division, Office of Pipeline Safety at PHMSA, joining us today as well. Thank you all for taking the time to be here. Next slide. This is our agenda for the hour. Because the report is substantial, we won't have time to go into depth on any one subject in the report, but we will have the report authors spend the first 30 minutes of the webinar covering the report's key messages and content. I'll start with the key messages, and then I'll hand it over to Errol Pinto to cover the legal and regulatory state of play of CO2 pipelines in the US. And then John Godfrey will present on pipeline safety, risks, best practices, and research. He'll be followed by my colleague Hugh Barlow, who will discuss the incident in Satartia, Mississippi. And I'll close out the presentation by covering the need for community engagement and the benefits of CCS. Following the presentations, I'll lead a short panel discussion with John and Max, and we'll close out the webinar with questions from the audience. So please use the Q&A function within your Zoom window throughout the webinar to submit your questions for the presenters or our panelists. Next slide, please. Let's start with the report's key messages. And the first key message is that CO2 pipelines are vital infrastructure required to address climate change. We begin the report by providing the climate context that supports this message. We describe what greenhouse gases are and explain that while CO2 is not the most potent greenhouse gas in terms of global warming potential, it is 200 times more concentrated in our atmosphere than more potent gases like methane. We show that the world continues to experience an unabated rise in the concentration of CO2 in the atmosphere since we started keeping records more than 40 years ago. And we described the consistent messaging from international bodies such as the Intergovernmental Panel on Climate Change, the IPCC, which has modeled all the credible pathways to limit global warming to 1.5 degrees C. And they continue to conclude that gigaton scale CCS is required by 2050. And in the report, we cite several recent studies that estimate the US will need to build a CO2 pipeline network comprising anywhere from 20,000 to 96,000 miles in order to scale up to that gigaton scale. So simply put, CCS and CO2 pipelines have to be part of the portfolio of climate mitigation solutions to reach net zero. Next slide, please. Our second key message is that CO2 transportation via pipeline is well established and regulated in the US. The US has more than 5,000 miles of CO2 pipelines operating with a strong safety record. And the safety of those pipeline operations is inspected and enforced by PHMSA or by states which have been authorized by PHMSA. And Errol will tell us more about that in his presentation, and Max and John can answer questions about regulations and enforcement during our Q&A. Our third key message is that to achieve net zero goals and remain competitive in a growing global marketplace for low carbon commodities and products, the US must address barriers to pipeline deployment, including permitting delays. In the paper, we describe the impact permitting delays could have on CO2 emissions in the US, but we also demonstrate that pipelines are the most common and often the most efficient means of transporting CO2 safely over long distances. In fact, in this figure on the right, we show that globally, 41 projects in operation or under construction use pipelines for CO2 transportation, and 195 of the 325 CCS projects in development also plan to use CO2 transport via pipeline. Our final key message is that early and sustained community engagement and education are crucial for enabling pipeline development. While we advocate in the paper for the need to significantly scale up CO2 transport infrastructure, we emphasize that how the country builds that infrastructure is equally important as the infrastructure itself. We describe how community engagement and addressing environmental justice issues are becoming required in some cases, such as when applying for funding from the US Department of Energy. The need for education and engagement is also demonstrated in studies that suggest the general public is unfamiliar with CCS. So CCS project operators, government officials, and community stakeholders should utilize the published and public environmental justice tools and community engagement guidelines to improve CCS understanding during project development. And we recognize that failure to engage communities or conduct ineffective community engagement can result in opposition to projects. So to hear more about some of these key messages and the content of the report, I'm now going to pass the mic over to my colleague, Errol Pinto, to discuss the legal and regulatory state of play in the US. Next slide, please.
Hello, everyone. My name is Errol Pinto. I'm the Senior Policy and Commercial Lead at the Institute. The legal and regulatory state of play in the US is nuanced, and it's clear from this map that there are certain regions in the US where pipelines are concentrated. There are over 5,000 miles of CO2 pipelines in the United States. And while several million tons of CO2 have been transported, as Joey mentioned in the previous slides, several models have suggested that we require about 30,000 to 96,000 miles of CO2 pipelines in order to meet the net zero targets that have been committed to by the year 2050. Next slide, please. As I mentioned, the legal and regulatory state of play is nuanced in the United States. The permitting regime includes many steps. There are levels of government involved in obtaining the rights of way, conducting environmental assessments, providing public notice, and undertaking community engagement. It's nuanced because it's split at the federal and state level. At the federal level, PHMSA regulates pipeline safety through 49 CFR Part 195. The siting authority is held by several federal agencies on federal lands. For example, DOI agencies like the BLM and the Forest Service. Offshore pipelines are regulated by PHMSA or by the BSEE at the DOI. At the state level, most states implement PHMSA's Office of Pipeline Safety certification to certify state-level agencies that then inspect and enforce pipeline safety regulations for intrastate gas pipeline operators. And several state agencies often adapt the regulations that exist in 49 CFR Part 195. Next slide. But there are challenges for CO2 pipelines. And this is because pipeline siting decisions are largely governed by states, except when pipelines cross federal land or rely on federal funds. And this is because states, not all states include CO2 pipelines in their statutes. Some do, but others do not. Additionally, pipeline developers must obtain access and rights of way. They do this through permits on public land or by purchasing easements to cross private land. Not all states provide a legal route to use eminent domain. Some states have clear requirements, but many have unclear requirements regarding how eminent domain can be used. Once pipelines are built, state level and PHMSA regulations are used to conduct maintenance and safety inspections and compliance with permits and agreements governing the public and private access to rights of way. With that, I'll hand it over to John.
Yeah, good afternoon, everybody. My name is John Godfrey. I'm a senior principal consultant with DNV here in the United States, and primarily focused on pipeline safety and pipeline design and construction issues. So next slide, please. What we have here is a very simplified diagram for carbon dioxide. In pipeline transportation, carbon dioxide is typically shipped in either its liquid phase or in its supercritical phase. The two together are referred to as dense phase CO2. This is the most efficient way to transport large volumes of CO2. The density is such that you get more tonnage, and you can easily control the pipeline operating pressures and the pipeline operating regimes in the dense phase. Pipeline safety is administered by PHMSA, and these regulations apply to supercritical CO2 pipelines and any pipelines that start as supercritical and eventually transition through normal temperature and pressure changes into liquid phase pipelines. Max Kiba can address more of that, I think, as we get into the Q&A this afternoon. Industry standards and recommended practices for CO2 pipelines are the same as for other hazardous liquid pipelines. This includes transportation of common fluids that we're all aware of, such as gasoline and diesel, but also things such as propane and ethane, butane. The same rigorous standards for safety apply to CO2 pipelines. And those are commonly governed by standards such as Federal Code, Part 195, Pipeline Safety, as well as the American Society for Mechanical Engineers. The goal is to develop integrity management programs and to build the pipelines so that you can construct them, operate them, and do it in a safe manner to prevent accidents throughout the life cycle of the pipeline system. Next slide, please. CO2 is, as well as being a simple asphyxiant in confined spaces, is actually relatively toxic. There's been a lot of studies on CO2 concentration levels. Some of the more common threshold limits for CO2 exposure are shown here. I will say that most of this is derived from occupational exposure. There's actually not established limits for emergency response levels, but this is something the industry and the pipeline operators and the public are engaged in. There is research going on in these areas, and it's something that is taken into account during the design and the routing of pipelines so that we understand what the risk of exposure may be. Next slide, please. When we talk about emergency response, we also have to talk about routing of pipelines. As it was mentioned before, there's a lot of agencies that are involved in routing and in issuing permits or getting easements for pipelines. But the main consideration in pipeline routing for CO2 is to try to avoid population areas as much as is feasible. It's always preferable to avoid any populated areas. That goes for almost all pipeline construction projects, but CO2 provides some or has some very specific threats that have to be considered. It's a heavier than air gas. It has a tendency to follow terrain if it's released. But the good news is it's not flammable, it's not explosive, and it disperses readily in the atmosphere. The insights from CO2 modeling help us choose the proper routes and help us minimize the potential risk of those routes, while we also consider the other risks that routes present. Pipelines generally are routed to avoid things such as geohazards and soils that are highly corrosive, or other things that may impact the integrity of the pipeline throughout its life cycle. Considering location of population and potential consequences is certainly something to consider as we layer in those other routing considerations. In terms of emergency response, operators are obligated to work with stakeholders when they're defining the pipeline's route, and they're also obligated under federal regulations to have written procedures that address abnormal operations and emergency response. Most common, pipeline operators use the incident command system to manage emergencies and help prepare for emergencies. CO2 pipelines are regulated just like any other hazardous liquid pipeline when it comes to requirements for emergency response plans. And operators work diligently to publish those plans and understand what the risks are. And there's some very good programs that are going on right now in coordination with Texas A&M University to help train emergency responders specifically to CO2 response. And the industry is engaged in that effort and moving forward. Another area that's ongoing is pipeline research. DNV is heavily engaged in researching the effects of CO2 releases as well as CO2 pipeline design. We've been doing it since about 2011. It also includes a number of large-scale tests that have been conducted at our Spadeadam facility in the UK. These tests have been used to help refine industry standards, to refine the software that's used to model air dispersion and potential impacts of a pipeline failure, as well as looking at particular things around pipeline design, such as material properties for the steel and what sort of design criteria should be applied to CO2 pipelines that may not be included in regular industry standards. And this research is ongoing. Currently, DNV has a couple of joint industry projects in the works. One is to continue to look at design and operation of CO2 pipelines and update our recommended practice, DNV F104, for design, operation, and construction of pipelines for CO2. And also a new project called Skylark, where we're looking to expand the body of knowledge when it comes to dispersion modeling, where we will be doing full-scale testing in complex terrains and a number of environments so we can better understand the effects of CO2 releases and how they behave in the environment. So with that, I believe I'm finished. I'll pass the mic on.
Brilliant. Hello, and thank you, John. My name is Hugh Barlow, and I am a carbon capture technology lead with the Institute. I will now present details regarding the pipeline failure near Setaukesan, Mississippi that occurred in February 2020. Next slide, please. On the 22nd of February 2020, a section of the Delta pipeline ruptured due to nearby soil movement. The Delta pipeline runs near to Satasha and transports CO2 from Jackson Dome in Mississippi to Delhi in Louisiana. Mainline block valves were closed to stop flow through this pipeline. However, CO2 present in the segment was released to atmosphere. The CO2 did not immediately disperse to normal background levels due to the unique combined effects of the still local weather conditions on that night, the area's topography, the density of CO2, as John mentioned, heavier than air, and the volume of CO2 released. A portion of this released CO2 traveled down a valley to Satasha. This resulted in higher than normal concentrations of CO2 in the air. PHMSA has investigated this incident and published its findings in a 2022 report. PHMSA determined that the incident was the result of soil movement, which led to a weld failure. The soil movement is believed to have been caused by heavier rain in the weeks prior to the incident. The higher than historical average rainfall, combined with the area's topography and soil type, is believed to have resulted in the soil movement. PHMSA has reported in their report that approximately 200 people were evacuated from their homes and 45 people sought medical attention at local hospitals. Next slide, please. Following this event, several actions have been undertaken by both the operator and PHMSA. Operator actions have included the development of higher accuracy dispersion modeling, which was used to reassess pipeline segments near to high consequence areas. As a result of this new modeling and reassessment, Satasha was reclassified as a could affect high consequence area. It is now included in the operator's public awareness program. The operator has also made improvements to their geohazard identification and monitoring techniques, including the employment of additional tools such as LiDAR, strain gauges, and slope inclinometers. The operator has also deepened their public awareness program for relevant authorities and responders at local, state, and federal levels. PHMSA actions following the incident have also included the incident investigation mentioned earlier, followed by a notice of probable violation issued to the operator, and ultimately a consent agreement between PHMSA and the operator. They've also undertaken new rulemaking and research to strengthen CO2 pipeline safety, as well as issuing an updated nationwide advisory bulletin to all pipeline operators regarding land movement and geohazards. For full table of actions, see Table 4 of Building Our Way to Net Zero Carbon Dioxide Pipelines in the United States. Next slide, please. For the conclusions of the incident, the release and the impacts it had on the local community were the combination of many contributing factors. Safety regulations, best practices, and rules for CO2 pipelines are designed to minimize the risk of serious incidents, such as this pipeline failure near Satasha. The event has resulted in a re-examination of industry best practices at all levels to further reduce risk and ensure public safety, including new rulemaking and research by PHMSA. The risk of geohazards has been highlighted to all pipeline operations, CO2 and other fluids, and it's been further highlighted since the event. CO2 pipelines do have a strong safety record since their introduction in 1972, with some of the lowest rates of incidents affecting people per mile of pipeline across the United States. Thank you, and now back to Joey to talk about the need for community engagements and the benefits of CCS.
Thank you, Hugh. We can move to the next slide, please. One important finding from our paper is that surveys suggest that communities are unfamiliar with or have concerns about CCS. And evidence suggests that community understanding is low, even in cities that are bolstered by the energy industry, such as Houston, Texas. A 2023 qualitative survey by Air Alliance Houston found that more than half of its respondents ranked their confidence and understanding of carbon capture technology below the midline value, so 5 or less on their scale of 1 to 10, with 10 being very confident. Other surveys referenced in our paper find similar results. So this underscores the need for education, engagement, and outreach. In the paper, we provide resources for project developers and operators or any stakeholder needing to engage with communities to build and implement robust community engagement plans. The first reference we provide is the new recommended practice published at the end of March by the American Petroleum Institute, or API. API RP 1185 is a consensus document drafted with input from members of the public, from government, and from industry. And the engagement guidelines are based on the core principles listed here, and it lays out specific engagement elements to be applied throughout the pipeline lifecycle, from early siting and design all the way through to abandonment and decommissioning. The second reference we provide comes from the U.S. Department of Energy, Office of Fossil Energy and Carbon Management, FECM. The FECM framework was published in 2022. It's free to download and provides 5 principles for successful engagement. And these include two-way engagement, so ensuring there's a dialogue, proactive early engagement, place-based engagement, meaning operators consider the unique circumstances, geographies, resources, et cetera, of each community. Building community-based knowledge, so collecting and sharing data with communities, and building engagement capacity, which meaning helping others scale their engagement activities in addition to creating and sharing technically accurate materials for stakeholders. Next slide, please. Part of the message we want to send with this paper is that CCS and CO2 pipeline projects can have positive impacts on communities. We describe in the paper how the current administration's Justice 40 initiative seeks to ensure 40% of the overall benefits of certain federal investments, including CCS projects funded by the U.S. Department of Energy, flow to disadvantaged communities. Justice 40 also requires community benefits plans that prioritize things like engaging communities in labor, investing in America's workforce, and advancing diversity, equity, inclusion, and accessibility. Outside of government, 2 recent studies have shown that projects linked to or enabled by CO2 pipelines may have positive effects on local air quality. The Great Plains Institute published a study last year with Carbon Solutions that showed that CCS technology applied during retrofit of existing point source facilities can reduce CO2 and other pollutants such as nitrogen oxides, sulfur dioxide, and particulate matter if the equipment to remove those co-pollutants is installed. They estimated this co-pollutant removal would have positive health impacts in communities that translates into significant economic value on the order of tens to hundreds of millions of dollars in some regions. The Clean Air Task Force conducted a smaller but similar study that found similar results. Their study of 2 cement facilities and 2 refinery facilities showed that adding carbon capture technology would nearly eliminate sulfur dioxide emissions, reduce CO2 emissions by 90%, and cut particulate matter emissions by more than 90% across all the facilities they studied. For nitrogen oxides, emission impacts were minimal, but they were reduced at the refinery facilities they studied. We also present findings of a study by Dismukes et al., a team at LSU, Louisiana State University, that considered the economic impacts of developing a local CCS market centered around the Gulf Coast Sequestration Project planned for Calcasieu Parish in Southwest Louisiana. Their study estimated that that particular CCS project could abate $11.3 billion of climate damage over the project's 30-year life. They estimate the project could generate nearly $1 billion of gross state product and $1.2 billion in U.S. gross domestic product. And all of that is in addition to producing hundreds of regional jobs during project construction and operation. So CCS projects, which are often enabled by networks of CO2 pipelines, can have real and sustained health benefits, employment benefits, and economic benefits to communities in which they operate. So I'd like to encourage all of you to read all about this and more, all the topics we discussed today, by downloading the report from our publications page from our website's publications page, which is globalccsinstitute.com. Next slide, please. And now I'd like to begin my conversation with Max and John. And again, thank you for those who have been submitting questions to the Q&A. We'll see those. We'll get to those in just a minute. Please continue submitting questions. There we go. Hopefully we can all see the panelists. So Max, if I could start with you, can you just give us an overview or describe how PHMSA regulates CO2 pipeline safety?
Yeah, definitely. Thanks for the question, and thanks to Global CCS Institute for having us. It might help to talk about the life cycle approach, because a lot of the questions we get are how do pipelines fit with some of the other projects, sequestration sites. So for anyone who doesn't know, PHMSA, and it's covered in the report and in this presentation, but we don't have siting authority, so we will oversee pipeline safety. Typically with us, we need an operator to register with an operator ID number called an op ID. And typically we will need, once they have to register with op ID, and then they have to notify us. Well, part of our regulation says at least 120 days before plans, procedures, but typically with these larger scale projects, we have asked operators to, send it to us much earlier in advance. But we will look at all aspects of design, construction, operation, maintenance, typically in these plans. PHMSA will, we will oversee interstate pipelines. And I think it was touched on in this presentation. If a state has certification, we have about 15 that have certification for hazardous liquid pipelines, which most pipelines currently are supercritical state. You probably saw that one. There are some questions I saw of interest in gaseous CO2. We are aware of at least some operators that are considering, and I think some of these are out publicly, but conversion of service of at least the natural gas pipeline to a gaseous CO2. So that's typically how we'll engage. And again, we'll typically do project reviews in advance, but not until the project is actually approved will we start doing, additional compliance reviews, if that helps.
Thank you. And continuing along the safety theme, at public meetings, some people are concerned that what happened in Satartia will happen in their community. So I'd like to ask, are the current safety regulations sufficient to prevent another Satartia-like incident?
That's a good question. I mean, quite honestly, I would say the regulations won't be sound until we have no incidents. We keep talking of a golden zero, but a lot of people know about Satartia. We recently had an incident in Sulphur, Louisiana, much smaller incident. It was a pigging receiver facility, but it still had a local shelter-in-place order. So we still have incidents. So, but at the same time, regulations alone, I don't think will prevent all incidents. It requires a good safety culture. And I will say some operators have it. Others occasionally miss the mark. So I think it's a more complicated discussion on overall. I think I do have full faith in PHMSA and state inspectors, the ability to try to do their best in making sure things are safe. But I think, again, in fairness, there are risks, unique risks to CO2. And what we've heard, I think it was addressed in this presentation, that CO2 follows a lot of the same requirements as Part 195. And what we've heard from pipeline safety advocates are the need to perhaps clarify or consider additional regulations that more specify the unique risks of CO2 and have some more specific requirements for CO2 in our regulations. So, and that's where among the things we're considering some form of our public meetings on areas we need to clarify based on public input.
You mentioned that PHMSA has issued a proposed rule following the Satartia incident. Can you give us an update on the status of that rulemaking and what the estimated timeline or what the process would be from here on out?
Yeah, I mean, we're hoping as soon as possible. It is currently under Office of Management and Budget Review, OMB, if anyone doesn't know, that their process to do a proposed rule has to go through. And it is publicly on the OMB's website, but they do what's called Executive Order 12866 reviews, which basically anyone that's impacted potentially by a rule has an opportunity to talk about it. It's pretty common. 12866 happens with interagency reviews, but they are considering, I believe, some public comments as well, at least considerations and questions. So we don't have a good timing. We do have a public website out there on our estimations, but quite honestly, that has shifted. The latest estimate, we're hoping to maybe have a proposed rule in June, but quite honestly, rightfully so. OMB is doing their part. It's a process, public engagement, some of the other comments. So there's a chance that that timing may shift slightly.
Thank you. This question can be for John or Max. If you both have insight on this, I'd like to hear it. Is there a minimum kit that should be used when designing a pipeline, the minimum safety kit? And sort of along the design lines, what determines whether a pipeline is buried or above ground?
Wow, that's a good question. That basically, the buried or above ground really goes to the environment you're operating in. Typically, pipelines are buried. That protects them from outside force damage, from sabotage, from other forms of accidents. There are some environments where the pipeline will be above grade. The most famous one, I think, is the Trans-Alaska Pipeline, where it's installed above the permafrost. But to your question, is there a basic kit? Yes, it starts with the overall design of the pipeline. What material do we specify? What grade of material? What thickness of material to ensure that the pipeline can safely carry the operating pressure? Then we take a look at safety devices. We look at modeling the pressures within the pipeline. Does it need relief valves? Does it need surge protection? We'll also look at things such as placement of emergency flow restricting devices, valves, as well as other safety devices, pressure transmitters, temperature transmitters out on the pipeline. And then go into a process of detailed construction specification. Everything from how the materials are manufactured and pumps are built to the qualification of your construction contractors and the qualification of the individual people that are working out on the pipeline, and making sure that those folks have the requisite experience and training to not just safely build the pipeline, but build the pipeline so that it doesn't have any latent construction or material defects that could affect its operation in the future. Routing is an important consideration in that, because when you're looking to route a pipeline, you're looking for the safest route when it comes to the public and the environment, but you're also looking at minimizing any potential outside damage or future damage during the life cycle of the line. So you try to avoid areas of known geohazards, as I mentioned, corrosive soils, but you would also look for things like constructibility. The harder it is to build a pipeline, the harder it is to build a really good pipeline. So looking at areas where pipelines can be safely installed to minimize the risk of any construction or material related defects. And some of this is addressed in the report. I think those are probably the big ones. Max, do you have anything else you want to add?
No, I fully agree with what John said. Just some examples of where we're considering transition from existing regulations to more specific regulations. The regulations do require the pipe to be compatible with whatever you're transporting, but very general in nature. And certainly with CO2, as we're hearing different phases, potentially different emitter sources, things like that, that's a pretty broad umbrella of what could be compatible. So we have heard from, based on public input, should we be considering additional requirements on, specific constituents in the line, not just CO2, but if there's H2S, depending on where the emitter source is, particularly as we're transitioning from enhanced oil recovery to, again, some of these ethanol plants and a few others where some of these projects are being brought up. Some post-combustion is more challenging as well. So those are some things we've heard about. Pretty standard ones are valve spacing. We recently also did a rule in 2022 of additional requirements for valves in general that apply to all pipelines, including CO2. So valve spacing is important. Public awareness, emergency response is very important, knowing what product you're transporting. Again, we already have existing regulations, but here's an area where we could be more specific for CO2. With most CO2 that's transported by supercritical, there is a very rapid phase change happening. And a lot of questions come up on fracture control. When it changes that phases and then it basically has that freezing effect as it turns very quickly to a vapor. Again, existing regulations kind of talk in general about a fracture control plan, but that's one area where we've heard members of the public say, you know what, we need something more specific on whether it's the material used or other aspects to improve fracture control plans. So That's just because some high level looks. And a big question from the public, again, I've seen some comments on if you're repurposing lines instead of new pipelines, is the pipeline going to be adequate for what's called conversion of service? Again, we have existing regulations that have conversion of service requirements, but very high level. So there's been some suggestions to have more specific requirements in place for conversion of service. And a big, and I think it's in the Satarsha report, the whole discussion of dispersion analysis and modeling to catch things like as Satarsha should be within a high consequence area that could be impacted. So things like making sure the dispersion modeling and potential, some people call potential impact radius on the gas side, but if anyone doesn't know, CO2 when it's released, it's not really a nice easy circle depending on the conditions and things like that. So having a good handle of, in the case of a release, where it could be impacted. So those are just some examples high level. Going from there, each project is a case by case basis depending on the unique terrain, things like that. So that's where you have to look, okay, where are these unique areas that are being considered that could be impacted based on the terrain, other operating parameters, which John kind of touched on, but those are just some other areas to be more specific. Yep.
Thank you. And one of the things you mentioned is emergency response, and CO2 has unique properties compared to some other fluids that are transported by pipeline, oil or natural gas. So could either of you speak to the difference in risk and emergency response to CO2 pipelines versus those other fluids or other hazardous liquid pipelines?
Yeah, I'll take a start on this one.
All right, I'll go second.
Okay. A big thing from Satarsha, again, first thing with Satarsha, even sulfur, big thanks and congratulations. It could have been thank you, could have been much worse if it wasn't for the heroics of our first responders. It could have been much worse. But some issues where basically carbon dioxide, in addition to asphyxiating the public, could have an effect and does have an effect on combustion engines. So things like, there was at least one individual or a couple individuals that their car just stopped working when they went through the plume in Satarsha. They're still dealing with some health effects today. Some questions have come up on whether emergency response vehicles can work if they're in that plume. So there are talks out there on whether you need EV type vehicles for emergency response and some of those aspects. The other difference, it's again, particularly when you're going from a supercritical or close to dense lake phase, you have that quick change in phases. So a lot happens. And other parts of the liquid side, we have what's called highly volatile liquids, HVLs. So in some cases, CO2 from supercritical to gaseous behaves a lot like HVLs, other than you don't have the flammability issues. So those are just some high level, but I'll defer to John on some other points.
I think you hit most of them. I think that one of the bigger considerations is the density of CO2. It roughly has the same density or specific gravity of 1.5 compared to air, which is about the same as propane. So it's going to spread out along the ground. It's going to disperse naturally into the atmosphere. But a lot of our standard emergency response protocols don't necessarily look for CO2. It takes special gas monitors that aren't part of the regular kit. And first responders need to be trained in setting the hot zones, the warm zones, the exclusion areas, so that they can safely evacuate people and they can keep people from getting into the plume if there is an accident. CO2 also disperses, so there has to be a good awareness of emergency responders for the local weather conditions. There's some great resources out there from NOAA that allow responders to do on-site dispersion modeling. They can take the actual weather conditions, they can anticipate where a plume may go, and we need to strengthen those resources and make sure that our responding community is aware of them and they have access to them. I think those are just to add on to the things that Max had already highlighted.
Yeah, and I have seen additional comments. One thing, among the constituents, carbon dioxide and water, that creates carbonic acids, and typically that will have some corrosive effects internally. So again, some questions we've gotten on other aspects on the constituent, and John hit it well on other aspects when that's released. Again, it's in the Satarsha report in general, but I think it also happened in Sulphur, Louisiana a little bit, like the expectation that it should disperse, but if there's certain weather conditions, in the case of Satartia, there was a temperature inversion effect where the product just couldn't disperse, and eventually, again, denser the air, it just couldn't disperse, and that's where a part of the aspects of the consequence was a little bit more in those aspects. So,
Thank you. Let's turn to the audience Q&A now, and you sort of touched on this, but there's been a few questions about the specification of the CO2 streams that are transported in these pipelines. What's in there? How much water? Are there other impurities? So if you two could speak to that, and also a question about toxicology. One audience member asked, "Is CO2 toxic in and of itself, or is it just the exclusion of oxygen that's the issue?" And I don't know if that's something that you have the authority to answer, but those are the questions.
I think I can address the toxicology one first, at least to give a simple answer to it, and hopefully point the audience to where they can get more information. CO2 is part of our normal respiration process. We have CO2 in our bloodstream. We have it in our bodies. It's just part of normal life. But at high concentrations, there is a neurological effect. It increases heart rate. It can cause dizziness and confusion, labored breathing, and even at concentrations that are not an asphyxiant, below the asphyxiant level, because it won't readily displace oxygen. But if it builds up in the body to high enough levels, it can be mildly toxic, even before it becomes an asphyxiant. The asphyxiation concerns are mostly in confined spaces. This is where you have a pump house, you have a metering building, you have something on a facility where you have a leak, and it does fill the entire space. That's where we worry about asphyxiation. The level of toxicity is going to depend on the person involved. Healthy, there are a lot of studies by the Navy, a lot of studies by NASA, because obviously they have to contend with that in submarines and spaceships more than we do out here on terra firma. But depending on the person, sailors and astronauts are usually pretty healthy, and they can tolerate a little bit more than, say, somebody with other health-related conditions. So I'd encourage people to get out, look at the studies that are out there. There's some new ones coming out of the UK Health and Safety Executive that are very good. And that information is continuing to evolve. I just encourage people to go out and look at it. In terms of the composition of CO2 and impurities in CO2, supercritical CO2 is an excellent solvent. Liquid CO2 is also a good solvent. Most of those impurities are picked up and carried in the stream. It's in events where the phase changes rapidly, where the temperature drops and it's converted to a vapor, some of those impurities drop out. And whether that's during the course of normal operation and maintenance or during an emergency, that's where you can get water dropping out of the stream, and it will combine with CO2 to form carbonic acid. It'll also impact the basically the dispersion of the CO2, as well as any fracture mechanics in the material. Those are all influenced by impurities in the stream. And there is research going on to better understand that. I would say to people in general, if the pipeline is operated in supercritical or dense phase, including liquid, and it's maintained in that phase, those impurities are going to move right along and not present an integrity threat to the pipe in and of themselves. So it's a process that can be controlled through proper engineering and design. Max?
Yeah, no, I'll just add, we, John touched on, there's ongoing research, and we've actually put out recent, and basically, based on public input, we had a public forum, R&D forum last year, but we have a couple solicitations out to get more into the question of, different constituents and kind of those aspects. So it's being looked at. I agree highly with John. That whole transition from, it's in the atmosphere and we exhale. Some people might consider it non-toxic, but under, enough concentration and certainly the scale of a release of a pipeline release, one can at least argue it's certainly hazardous. Well, anything generally in the regulations is hazardous to some degree. But two, I think John touched on a few others. There's some OSHA feedback and guidelines in there. And sometimes, interestingly, there's another part of PHMSA that does vessels, lithium batteries, train cars, rail cars, things like that. They have what's called an emergency response guide. Interestingly, some people there might be confusion out there that they look at that emergency response guide on exclusion zones and levels of hazard, but typically those are pretty small vessels, almost small containers up to maybe a rail car. But they don't quite count for, again, supercritical releases, and definitely not the scale of a pipeline release. So I would say, again, I'd agree wholly that you have to talk about the scale of the potential product being released, where again, the concerns of toxicity levels and those kind of things are brought up.
And just to be clear, is there a regulation or a statute requiring a specific CO2 composition for CO2 pipelines?
I'm not aware of any, unless John has something from some of the other standards out there.
No, I'm not aware of one either that describes a specific concentration. There may be other jurisdictions. I'm focused on North America, but in the North American market, I'm not aware of any specific regulations. But it is something that I know designers take into account, and it's controllable. You know, your carbon capture technology, you can use dehydrators, you can use scrubbers, you can reduce your impurities in your system. And we just have to give good guidance to the operators on those design targets.
Let's see.
Yeah, and I'll just add, from the PHMSA perspective, and again, what we hear from members of the public is like, let's try to have comprehensive regulations and requirements that can cover all phases, and regardless of whether it's a small leak or a large rupture, making sure we have something that accounts for it. So I'll just add that. But again, that's something that's been brought up publicly on some things we should consider.
You touched on this previously, I think, but maybe you could explain a little bit more about what goes into, well, how feasible it is to repurpose a natural gas pipeline, and what goes into those, what considerations go into deciding whether or not you're going to repurpose a pipeline.
You want to take that, John, or?
I can start. I would say the first thing you'd look at would probably be your material properties. Take a look at the line pipe itself. What's the strength? What's its resistance to fracture, its toughness? And consider if the materials of the pipe are compatible with, the potential for fractures in CO2 pipelines. That's primary first concern. Then I would look at the equipment you have installed out on the pipelines. CO2, as I said before, is an excellent solvent, but it does bad things to soft goods. So elastomers and seals and your valves and your pumps and your meters. What other installed equipment do you have out there on your system that could potentially be impacted by CO2? And methodically walk down that design and start to eliminate any of those potential hazards. It's not inconceivable to do it. But it requires a lot of engineering, and it requires a lot of investigation. You have to know what the properties of that pipeline are before you make the decision to convert it to a different service.
Yeah, and I'll agree with a lot of John said. I mean, a little more straightforward one is probably conversion from natural gas to gaseous CO2. But if there's any consideration going from natural gas to definitely supercritical or liquid phase, that's where you're getting into, you definitely have to control the pressure, the temperatures to keep it in that supercritical state. So you're changing from some form of, compression to more pump stations or other aspects, again, to have that aspect. And again, considering those changes from everything John said, but also in the case of a release, as you have those quick phase changes. So again, those are things that have come up publicly on things that should be considered on unique aspects of conversion to service. There are some, and John talked about materials, but there's some consideration and work and even research out there on other materials like composite piping, that, it's reinforced thermoplastic or other materials that maybe those are better avenues, particularly with some of the internal corrosion concerns and those aspects, that certain composite materials can still have the same pressure as, say, steel pipelines, but you might not have as much of the corrosion effects. The failure modes might be slightly different in some of those aspects. So there are some operators and industry that's doing, and us, that are considering research on different composite materials, including for CO2 and even some other aspects like hydrogen and a few others.
Maybe one more safety question from the audience. How are CO2 pipeline ruptures detected? Can they be detected with automatic systems? Or do they require manual monitoring, such as overhead flights?
That's a good question, and there's a good answer for it. CO2 behaves pretty much like most other hazardous liquids when it's in the pipeline itself. The pipeline doesn't really care what's inside of it. Your typical pressure and temperature monitoring, real-time pipeline monitoring and surge analysis will be very effective for detecting pipeline releases in CO2, much like all the other liquid pipelines out there. In terms of aerial overflight, aerial patrol or right-of-way patrols, it's going to be different. And there's going to have to be some training that's going to be required of the personnel that do that, because CO2 is, it's not visible. If you have a small leak out on your line, you're not going to see a cloud of CO2. You're not going to necessarily see dead vegetation on the surface or any other indication that you've got a pipeline leak, but you may see ice formation. You may see an ice ball form on the surface. They're just different things that you have to get out there and look for. And a lot of the instrumentation that we use for detecting, say, natural gas leaks through an over-the-ground survey would have to be significantly refined to identify CO2 releases. So there's more work that we can do there. But a lot of the traditional methods do still apply.
Yeah, I'll agree
Max?
with John. Yeah, I'll agree with John. Many pipelines out there are remotely monitored and controlled. The question or challenge or concern out there are things like smaller releases. So for instance, natural gas, typically in lease distribution systems closer to home, some transmission lines, they are odorized. But there is a question on one, if there's an effective odorant that could be used in CO2, or, what are the impacts of the CO2 stream that could impact the odorant? Or yes, do you need other more sophisticated leak detection systems that will still find a unique signature of CO2 compared to, say, methane or something else? So again, the technology is out there. It's a question whether you can fine tune it, and particularly for smaller leaks. And then a next step, again, how can you notify the public in the case of a release? Can you provide something to the public to say, hey, I'm going to know there's a release in my area? Some folks have looked at oxygen monitors that, when CO2 is released, the oxygen levels will generally go down. So there's folks that are also looking at oxygen monitors in addition to more specific leak detection, looking for that unique signature of a CO2. So those are just some examples. But I'm with John. It's generally possible. It's just a question of, can it be adequate enough and quick and reliable enough to see the signature of both a large rupture and then a small leak as well?
We only have 2 minutes left. And I'd like to ask one last question. So you'll each, if you want to speak to it, we'll have to be very brief. Pipeline development is complex for lots of reasons. Are there any policy improvements that either of you know about, or ideas you have that could streamline or accelerate that process?
I could just say, actually, just earlier today, in the last 2 days, there's a interagency government task force that's looking at a lot of those aspects. But a lot of questions came up on, what's the right balance of streamlining the process? But there was a good discussion on the need for community engagement, which again you touched in your report. What's the right question of notifying folks and things like that? So to me, I think at the end, any kind of project development, pipeline projects, community engagement, getting the community engaged earlier, look at the unique considerations for each community. It's not one size fits all for public engagement. A unique, Iowa might have unique considerations different than, say, another area of the country and things like that. So if you are a developer and others, try to engage early as possible. And again, see the unique considerations or concerns from those areas of members of the public.
I would agree with everything Max said, and I'm encouraged by the Intergovernmental Agency Task Force to look at opportunities to streamline permits, opportunities to reduce some of that risk for pipeline developers, to provide more certainty in the permitting process. I think that would be helpful. But I also want to say that what you've done here, what the Institute has done here in publishing this white paper and getting this information out to the public and encouraging this discussion I think is going to go a long ways as well. And I would just encourage people to get engaged, participate in the discussion, educate yourselves, learn about these systems, and what we can do to help develop the pipeline infrastructure to push this forward. So
Thank you.
good
I
job.
hope that's the case. That was our intent with this paper. And I invite everyone to go to our website, globalccsinstitute.com, to download the report. It's listed under the resources tab on the publications page. You can also find it posted on our LinkedIn and X social media accounts. You can also sign up for our newsletter at the very bottom of our homepage to get regular updates about what's happening in CCS. And I would just like to thank you, Max and John, and all of our presenters today. Thank the audience for their time, for joining us today. We hope to see you again soon, and thank you again, and have a great afternoon, everyone. Thanks for joining us.